So I'd like to discuss how to solve this rather nasty equation that you see in front of you. It's a first-order differential equation, and this is an equation that there is no way to solve exactly, at least I'm not aware of it, but nonetheless, using the ideas that we discussed in class, it is possible to construct an accurate approximate solution. So to do this, what we remember is, as we discussed in class, the equation has three terms. So, and we're going to label the terms, as we did in class, by just numbers A, B, and C. And of course, the equation actually is enforcing the relationship that A plus B is equal to C. So we are interested in understanding what the solution is like when x is large. So we want y of x when as x goes to infinity. That's the question that we're going to ask. And so the question is what is going on? What is the dominant balance? And so the way to do that is to basically make guesses about which of the terms we think are important as x goes to infinity. Now, as we discussed in class, it is generally the case that if you have an equation with three different numbers in it, that a plus b or c, two of them tend to be bigger than the third one, and we can use that to our advantage to find a good solution. So to do this, let's ask what happens when a is large, or when x is large. And so the three possible balances that can occur are the following. So we can either have a plus b is equal to 0, we can have a is equal to c, or we can have b is equal to c. And so each of these three relationships, each of these three symbolic relationships represents an equation. So for example, a plus b equals 0 refers to the equation y prime plus x squared over x squared plus 5y equals 0. So a equals c is the equation y prime is equal to 6 over x plus cosine of x. And b equals c is basically has the other two terms of the equation, namely this one and this one, being set equal to each other. So what we need to do is go through each of these possibilities in turn and try to understand what they imply about the solution. So okay, so to do this, what I'm going to do is just erase this. So I hope that this is good. So I'm going to erase. Can I erase? So I'm going to erase. Oh no, the computer is not letting me erase. Okay, since the computer wouldn't let me erase, let's just continue and look at the equation that we described before, which is, let's just start with a plus b is equal to 0. That's the first balance that we have. And the equation for that, just to write it down again, corresponds to dy dx plus, it was x squared over x squared plus 5y is equal to 0. And so we're interested in what happens when x is large. And now here comes one very interesting idea that makes this much simpler. So you could actually solve this equation exactly using separation of variables, and that's a lot of work, or it's a lot of algebra. So a slightly simpler thing to do is to realize the following thing. If you look at this coefficient here, that's multiplying the y, which depends on x, you will notice that as x goes to infinity, so as x gets very large, then this number goes to 1. Because when x is large, this basically becomes, right, x squared over x squared, and it goes to 1. So for that reason, actually what this equation is it's actually the equation y prime plus y is equal to 0, which has the solution that y is equal to e to the minus x. So what that means is that if the dominant balance, that a plus b equals c, were true, that y is equal to e to the minus x, and that states that the size of both a and b, namely of both of these two terms here, are of order e to the minus x. Now, as we discussed in class, in order for this to be consistent, so for consistency, so let me just write this down, consistent, so consistent question mark, what we need is the size of a and b to be much larger than the neglected term, which was c. And you will recall that c basically had the form it basically had a 1 over x plus cosine x in it. I actually forgot a little bit what it was. My memory is bad, everyone. I'm sorry. But the point is that when x is large, just using the same trick that we used before, this number has a size which is approximately equal to 1 over x. And the fact is that at large x, 1 over x is much bigger than e to the minus x, and so therefore c is largest. And so the consequence of this is that, surprise, surprise, that this is not consistent. So here, let me cross it out in orange or some funny color just to basically make it clear. So it's not consistent, so this doesn't work. So we have a no here. Okay, so to finish this off, let's do the one other balance. There are two other possible balances that we can do. We can do A equals C or B equals C, but just to make this shorter, I'm going to do the one that works, and you can all, as an exercise, go and check the other one that is left. So it turns out the balance that is the correct one is B equals C. And just to show you that, so that, remember, corresponds to x squared over x squared plus 5. Y is equal to 6 over x plus cosine of x. And for the reasons that we said before, this term, when x is large, is just y, because the coefficient, this coefficient here that we were talking about, this coefficient becomes 1. And this term, basically when x is large, x is much larger than cosine of x, right? So we know that x is much, much larger than cosine of x, and the reason is, at least if you look at the magnitude, is because cosine of x, so cosine of x actually has a magnitude which is bounded by 1. The largest that cosine of x can possibly be is 1. This is something you'll remember from trigonometry and circles and things like that. And so therefore, this term here, 6 over x plus cosine x, becomes approximately 6 over x when x is large, which essentially implies the law that we expect that when x is large, y should be given by 6 over x. So is this consistent? So we have to check consistency to make sure that this is okay. And for that, we simply need to make sure that the term a, which is dy dx, is smaller than the terms that we've kept, either of these other two terms in the equation. But if y is 6 over x, then dy dx is minus 6 over x squared. And if we could calculate absolute values, right, then that's just 6 over x squared. And the fact is that 6 over x squared is smaller than 6 over x when x is large. And so the consequence, so that is, this term is smaller than this term, and so this balance is consistent. So therefore, in summary, we have argued that when y is large on this original equation that we wrote down, that what we expect is for any initial condition, y should go to the law 6 over x. And so for any initial condition, for any y of 0, as x goes to infinity, we expect y to go to 6 over x. And this is sort of, I think this is a bit of a remarkable result. And the next step is to check it using the computer to see if it indeed obeys this law, and that will be the subject of the next video.